EDX Core Pure, Matrices 3, Determinants and Inverses. The inverse and determinant of 3x3 matrices. The inverse of a 3x3 matrix. You need to have a calculator that will be able to find both the determinant and the inverse of a 3x3 matrix. Use the matrix facility on your calculator to check that your calculator handles matrices. The relationship that we need for a 3x3 matrix is that T times its own inverse is the same as doing the inverse of T times T will always give us the identity matrix. So here we have a matrix A and a matrix B. If you just want to pause the video and have a go at finding the inverse of this matrix on a calculator and times it by the original matrix A. You should have found that when you multiply A by its inverse, you get the identity matrix, and you should have found that the inverse of A was indeed the matrix B. So you should have A times B is the same as doing B times A is the identity matrix. Hence A and B are inverses of each other, as their product gives the identity matrix. You can check inverses manually by simply multiplying the matrix by its inverse. If it doesn't give you the identity matrix, you must have made a mistake. The notation used for the determinant of the 3x3 matrices are the same as 2x2 matrices. So you might call it determinant of A in this form, or you may use this form. The Greek letter delta may also be used. The determinant is a number that may be positive, negative, or 0. If the determinant of A is 0, then T is said to be a singular matrix for any n by n matrix. Examples to try. So, using a calculator that can handle matrices, have a go at finding the determinant of these two matrices. You can pause the video whilst you do that activity. So the first result suggests that the inverse of the original matrix 1, 3, 2, 5, 1, 4, 6, 2, 3 would exist, and we'll be looking at how to find that in the next recording. And the significance of this result, the determinant of this matrix is 0, suggests that if the inverse of a matrix contained 1 over the determinant, then we would end up here with 1 divided by 0. So that suggests two things. First, that the inverse does not exist, and if we did it on a calculator, the calculator would give a maths error when you tried to find the inverse of the original 3x3 matrix. In the next session, we're going to be looking at the determinants and transformations.